Determine the interval of convergence for this power series here. So we're adding up, we've got our unknown x to the n over 2 to the n times n factorial. Now, I look at that, and this is just a guess right now. We'll have to do the math to back it up, but I think 2 to the n factorial grows really, 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 really big, way bigger than any x to the n will. So I'm going to guess that the interval of convergence is going to be all real numbers. Okay. As I say, that is a guess. Okay, you can't just call it a day and say that must be what it is. You've got to do the math to back it up. But the more you do these sorts of calculations and this sort of work, the more you develop a sense of, oh, there's my power series. I think the radius of convergence will be 5 or 1/3. Or, you know what, I think the interval will have both the endpoints included. Or, you know what, I don't think one of the endpoints is going to be included because I think I see, if you plug in a value, a p-series. You can start working ahead and developing a sense of this stuff. Right? But either way, we've got to do the math to back it up. So we got x to the n, 2 to the n, n factorial. So what should we do to try and understand the interval of convergence? Well, I'm going to use either the root or the absolute root or absolute ratio test. Because of the n factorial, I'm going to use the absolute ratio test. But you don't have to. You can use the absolute root. You're just going to eventually have to do the nth root of n factorial, which is definitely something you probably want to know at some point to have seen that done. Okay. But usually when I see factorials, I tend to just default to our good friend, the ratio test. Alright, now we can simplify this. You can show more steps if you want, but most of the 2's will cancel out. Most of the x to the n's will cancel out. Guess I should be writing this a little nicer. Just the power of n parts should cancel out. And if you're really experienced, you can say, well, the n plus 1 factorial over n factorial, that's just going to leave an n plus 1. Okay? Now, if you're uncomfortable with that, of course, show more steps. Okay? You don't have to show off. People who show off, try and skip steps when they're not comfortable, will usually make mistakes. Okay? So there we go. Now, 2 and n plus 1, these are already positive. So we can just say absolute value of x over 2 n plus 1. Now, absolute value of x has no n's in it. It's fixed. It's constant. So is the 2, really. Okay? What's happening here is we've got a limit. As n is changing, x and 2 are unchanging, and the denominator here is just growing and growing and growing. Anything fixed and constant over something that's just getting big, and then bigger, and then biggest, okay? The whole thing's going to go to 0. Okay? The whole thing's going to go to 0. So it doesn't really matter what x is. Our row value is going to be 0. Okay? So what does that mean? Okay. So regardless of x, row is 0, which is less than 1. So our series, you could say absolutely converges. We're just interested in convergence, period, because we want the interval of convergence. Okay. So our series converges for all x. Okay. If we were to imagine a number line centered at 0, because that's the center of our power series, we get convergence everywhere. Okay. So the interval is going to be negative infinity to infinity, or you can just say all real numbers. Exactly what I predicted would happen. Okay? But we didn't rest on the prediction. We didn't say, that must be what happens. We did the math. We backed it up. It turns out the value of x doesn't matter. You always get convergence. Okay? So we'll just say it converges everywhere. And there we go. So the interval of convergence, all real numbers in this case.